Welcome back to Maths with Mrs. J. We've introduced a visual idea of what a limit looks like coming in from the right and from the left. I now want to actually do some examples using graphs, some relatively simple graphs, to see what the limit is from the right and from the left. Some of these examples are particularly interesting because you will find that sometimes the limit is not actually equal to what the function equals at that particular point. Our very first example is an example just like that, in fact. As you're coming in towards 8 from above, so you're coming in, getting closer and closer and closer to 8 with your x. Your y value is getting closer and closer and closer to this value here, which is 7. It's not going to actually ever equal that, but the limit is that because it means that it's going to get infinitely close. As your x value is getting towards 8 from below, so you're getting closer and closer and closer and closer, again, your y value will get closer and closer and closer to the value of 7. Because those two values equal each other, we can say that the limit exists and that the limit is 7. So the limit, as x tends towards 8 of f of x, exists because the limit from above and below is the same, and it's 7. Now have a look at this. This is the actual value of the function when x is 7, and that is actually not the limit. So that's an interesting example. The one to the right here is an example where the function doesn't even exist for x equals -4, yet the limit exists. As you're tending towards -4, the function is tending towards -1. So you're coming in from above, the function's coming into -1. As you're tending towards x equals -4 from below, coming in from this way, again, your function is coming in towards -1. So again, because the right-sided and left-sided limits are the same, we say that the limit exists, and the limit is of f of x is -1. All right, so the limits have to be the same from both sides in order for that function to have a defined limit. Okay, let's press on. Okay, we've got some more examples here. In this case, we've got very clear discontinuity here. And this is the value of x for which I want to calculate the limit, or at least attempt to calculate the limit. You can see here that as you're coming in towards x is 0 from above, so from the right, your function is coming in towards a y value of 8. So as you come in from above, the limit will be 8. The y value is not actually going to equal 8, but it is approaching that. And that's what limits are about. As we're getting infinitely close to this, what is the y value getting infinitely close to? As you're coming in from below, this is the relevant bit that you're looking at. And as we're coming in from below, when x is always just a little tiny bit less than 0, the y value is going to approach 4. Now, because these two values are different, the limit does not exist. So the limit, as x tends towards 0, in this case, does not exist. All right, we can pretty much tell that from looking at the graph. There's a very big discontinuity there. Limits and continuity are not the same thing, but they do go hand in hand. If a limit does not exist, quite often that's because there is a discontinuity. All right, let's have a look at this next one. Again, there are sort of two important x values here. X is -5 and x is 6. Obviously, if you wanted the limit of this function when x is -8, you can just work out the y value there. That's not a problem. It will be coming to the same value from above and below. Not a problem at all. The reason I've picked these values is because clearly we're dealing with a piecewise function, and so the limit from above and the limit from below quite possibly could be different. As we're coming in from above here, coming in this way, the function is tending towards 5. Y value is tending towards 5, and it will actually equal 5 because that is a closed in dot. Here we have an open circle here. So as you're coming towards x is -5 from below, you're never actually going to reach this y value, but you're going to approach a y value of 1. So that limit does not exist. The limits from the right and the left are different, and so we say that limit doesn't exist. So does not exist. Have a look at this other situation here. As we're coming in from the right, the y value is approaching 9. As we're coming in from the left, the y value is also approaching 9. We've done one like this before. This is a situation where the value of the function at that point is actually not the value of the limit. The limit is 9 because y is getting infinitely close to 9 as you come in from both sides. So that's something to bear in mind. All right. Let's move on and do a couple more examples. Okay. Here we have an interesting graph, again, some sort of piecewise function. We did look at this in our very first video. The two sort of crucial x values that are involved here are, of course, when x is -2 and when x is 3. I have also, just for interest, got us to do the limits when x is 0 from above and below, just to show how that works when a function is perfectly continuous at that point. Right, having a look here, as you're coming into x equals -2 from above, you're actually coming down here to a y value of -1. As you're coming up to x equals -2 from below, you're coming in this way, your y value is actually coming in towards 2. Now we can see from the function itself, there is a discontinuity there. So it makes sense that that limit does not exist. You're not heading in the same direction, all right? You're not tending towards the same number. If we're doing the limit towards 0 from above and below, well, in both cases, clearly, y is just tending towards 1, so there's no issue there. That limit does exist and is 1. If you have a continuous function, if the function is continuous and exists at a point, then the limit will just be whatever the y value is there. Having a look over here, this is another example where as you're coming in from above, you're tending towards 0. As you're coming in from below, you're also tending towards 0. So the limit of this function is 0. The value of the function at f is 3, at x is 3, should I say, is -1. That is not the same as the limit. All right, so we need to be just a little bit careful about understanding the difference between the value of a function and the limit. Sometimes they're the same and sometimes they're not. All right, let's press on. Okay, just introducing some different terminology here. You can write it the way I wrote it on the previous slides, or you can write it like this. You can say as x tends towards 2 from below, as x tends towards 2 from above, f of x tends towards, etc. Now, here we have the rule and the graph. In my next video, I'm going to be showing you how to do it if you just have the rule. It's good to have both here because it gives us a little bit of both to look at. As you're coming in towards 2 from below, you're coming in towards here, the y value is tending towards -5. Why is that? Well, this part of the graph is in play. X is less than or equal to 2. So if you sub in x equals 2 into this, you get -5. That's why you get that y value, because that function is what you're evaluating there. Coming in from above, now this function is not valid to be used when x actually equals 2. However, to work out what that function is approaching as x approaches 2, you would sub in x equals 2. And of course, you will get 2, right? Negative 2 plus 4 is 2. Clearly, that limit does not exist because the limit from above and the limit from below are different. This one here, just quickly going through, we have two sort of important x values here. We can see that the function is continuous through these two x values. And what happens is, as you're coming in from below, your y value is negative 4. As you're coming in from above, your y value is also negative 4. So the limit exists there and is negative 4. As you're coming in here from below, you're coming towards 0 as your y value. As you're coming into here from above, your y value also tends towards 0. So the limit there, so limit as x tends towards negative 2 of your function is negative 4. And the limit as x tends towards 2 of your function is 0. Okay. All right, now I've done another slide just so that you can have an opportunity to try some yourself. So you're welcome to try those ones either from the rule or from the diagram. Obviously, it's easier from the diagram. I'm not going to go through those ones now. The last one I wanted to do with you is some limits where we have asymptotes. As we're coming in towards 1 from above, then what is happening to our y value? Well, it's tending towards infinity. I've gone back to the different sort of terminology here. You need to be able to recognise and use both. As you're coming in from below, it's also tending towards positive infinity. So we could say that the limit of this function, f of x, is infinity. Clearly, the function is discontinuous here, and yet the limit still exists. Another thing to think about. Here we're going to negative infinity and negative infinity. The limit is the same from both directions, so the limit exists and is negative infinity, but there is a discontinuity again. Bearing in mind that a negative infinity or infinity limit is not quite the same thing as an actual number limit. If you have an actual number limit that exists, the graph will be continuous there. So things go a little bit different once you get up to infinity.